Nothing is progressing faster than computer-aided automotive technology. Why, in 20 years, cars have gone from being dumb hunks of rolling metal to having more computer power on board than the lunar lander. But like a spaceship, the brains are there to help pilot the vehicle more safely. And from a recent visit inside the labs of one high-tech supplier, it's clear we haven't driven anything yet. You've heard the acronyms and terms in our Motor Week road test. ABS for anti-lock brakes, a computer-aided hydraulic system that helps maintain steering control and prevents skids during panic braking by eliminating wheel lockup. The same sensors help prevent skids while accelerating in slick conditions with brake-activated TCS for traction control system. And lately we've been raving about ESP, that's Electronic Stability Program, that extends ABS and traction control technology to help coax a vehicle through corners the way the driver intended. And while you may not completely understand how these marvels work, most new vehicle buyers do understand that these electronic vehicle dynamic systems act as something of a safety security blanket. Almost like an invisible co-pilot, they can react faster to unexpected driving conditions than most drivers can do themselves. But developing vehicle dynamic aids that help fill the consumer's unquenchable desire for safety without also causing more highway distraction takes a big commitment by automakers and their suppliers. So firms that specialize in electronic vehicle dynamic systems are rapidly expanding. And that's the reason for this new North American original equipment headquarters for Continental Tevis Incorporated, one of the largest suppliers of electronic driving aids. The purpose of this 250,000 square foot research, engineering, and prototyping facility is to not only speed up improvements in existing systems as well as individual components like sensors, but to develop integrated driving systems that take advantage of the ever-expanding computer power in our cars. North American President William Kazera explains.
We have the unique ability to integrate tires with brakes and air suspension to bring the car manufacturer a lot more value than what, for example, anyone could do 2 years ago. And we're very unique in that respect. So today we have significantly more engineering capacity than we did last year or the year before. And the demand continues to be strong.
Integration is the key word to meeting the demands of automotive chassis designers. This integration and evolution has already progressed from ABS to traction control to stability systems like ESP. Indeed, around the cavernous vehicle development garage were displays that show where the industry is today. But in nearby labs where the paint was barely dry, work is well along on new technologies that can detect and react to other potentially dangerous driving conditions like rollovers. And for electronic systems like ESP to coordinate with mechanical chassis suspension components like shocks and springs, all to improve cornering stability further. Indeed, that was the focus of the designers of the multi-dimensional 2001 Audi Allroad Quattro. The Allroad, with its variable drive height, is the first vehicle to connect an intelligent air suspension to a chassis with electronic brake, acceleration, and cornering skid control. In the Allroad, the ride height automatically lowers to 5.6 inches at high speed to lower the center of gravity for flatter cornering. Yet it can raise to 8.6 inches when off-roading is the Allroad's mission. To Continental Tevis, the Allroad is another important step, but hardly the last one. Felipe de Quater is Chief Engineer of Chassis Systems for Continental Tevis.
By now you have electronic stability control systems, which are, let's say, a sophisticated brake extension system, if you will. We are working on air suspension, intelligent air suspension systems as well. And of course the future will be is that these two will interact in a far more extensive way.
For instance, in the near future, when an ESP system senses a cornering mistake, not only will brakes be selectively applied to keep the car on course, but the air suspension will simultaneously adjust ride height at one or more corners of the vehicle to shift weight distribution for more steering precision. Meanwhile, even more sensors, some inside intelligent tires, are actually measuring the forces between the tires and the road. Also, the integrated dynamic system can react faster and add control that keeps the vehicles and occupants secure. But there are plenty of critics of these electronic driver aids. They bemoan a loss of personal control behind the wheel from too much microchip intervention, and with that, a loss in the very spirit of the open road. Well, from what we saw, that's unlikely to happen at the Continental Tevis Labs. The men and women who are developing these systems are enthusiasts too. What do they see as the goals of their work? Again, William Kazera.
A consumer will be able to experience enhanced performance, enhanced safety, feel more comfortable, and at the same time continue to have fun in driving the automobile.
In other words, an America that drives safer is also one that keeps the automotive love affair going strong, even if they do get a little help now and then.